אני פיני רזניק, אני כן מדבר עברית, אבל לא הפעם. הסיבה שאני אעשה הרצאה באנגלית, כי אני לחלוטין לא רגיל לעשות את זה בעברית, מעולם לא הרציתי בעברית. אני גר בערך 15 שנה באמסטרדם, ולכן אני עבור לאנגלית, ואתם עדיין יכולים לשאול שאלות בעברית אם בא לכם. Okay, so my name is Pini Reznik. Yeah, so I'm originally sort of software configuration manager. Yeah, so I started my career in Israel, in actually Checkpoint, like probably half of Israeli IT. And I spent the last decade or so working on cloud native technology, starting from Docker in 2014, from the moment it started, but basically from the beginning, right? So we grew up with the cloud native ecosystem. We built really big cloud native systems for really large companies like household names like Adidas or Zara or things like that. So really big ones. And when I moved on from container solutions to the next thing, sort of thinking what to do next was almost obvious that the next thing is somehow related to sustainability. So first, a question: how bad are bananas in terms of sustainability, carbon emissions specifically? Any guesses? Are bad, terrible, like amazing?
Medium.
Medium, okay. I'll answer at the end, yeah. But it's a very nice book that really helps to get sort of perspective on carbon emissions. Okay, so is it actually happening, right? I'm not going to argue with you, right? That's not really, I'm not going to convince anyone if it's happening or not, but I mean, the data says it is, yeah? You don't have to believe in it, right? So if you don't, I'm not arguing. The thing is that we already, in 2015, there was an agreement, Paris Agreement, to limit the carbon emission, the climate change, the global warming to 1.5 degrees. We are not quite yet there, but we are very close to crossing it. So we are going to cross it, right? So there is no point in arguing. The question is how far it's going to get. Like if we're at 1.5 degrees, it's quite not so good. If it's 8 degrees, it's terrible, right? So it's still open question how far we are going to get with it. But it is happening. And a good piece of good news, the bad news, it's happening still. And by the way, this dip, it's COVID, right? So during the COVID, the carbon emissions dropped by 5%, and the next year they picked up back, right? So actually, it wasn't that, I mean, it was useful, but not that dramatic. And it all entirely picked up. The good news is that all the developed economies are going down quite significantly, right? So we are past the peak, except growing economies like China and India. China is probably already at the peak right now, but India is going to grow quite dramatically, and the rest of the world too. Specifically brought Israel. Israel, like most of developed countries, going down, right? So we are past peak, but there's still very, very, very long way to go. So what the governments are doing, and most governments actually doing nothing, right? Yeah, unsurprisingly. But there are few that are actually doing a lot more than you would imagine. The strongest one is EU. This is a real thing. It is already confirmed and rolled out throughout the EU, 27 countries, right, an entire economy. And the commitment is 55% reduction of carbon emissions by 2030. This is a law in EU, right? And this is, if you think that you don't care, actually you should, because there will be carbon taxes for whoever wants to sell into EU and doesn't comply. So actually, EU is not going to just enforce it for itself, but also for the countries that want to trade with EU. The rest of it is actually 90% reduction by 2050. The place it's actually right now is that companies above certain threshold, 750 people, need to report their current emissions this year, so next January. And actually, in many countries, the carbon tax is already in place. What it means is that if you are emitting more than you're allowed, then you're going to pay for it, right? So it's not just tree-hugging exercise, right? There will be a price to pay in dollars, in euros in this case. So why we should care, right? Because we all care about the airlines, right? When we go on the plane, we're like, yeah, that burns a lot of carbon emission, like a lot of carbon. But actually, IT is already way above the airlines. IT industry is 3 to 5% of total carbon emissions of the world, while airlines is only 2.5%. So actually, we are emitting more than airlines. And the blue line is the demand, expected demand on IT services, especially driven by AI. Everyone talking about AI, right? And building new data centers and stuff. Actually, this is the emissions line, right? The red line is emissions line. That's what is happening in Europe, right? So you need to comply to this line and still provide this demand, right? Unless we can decouple ourselves from carbon emissions, we cannot provide the services that the customers will actually need. And there is already, most of EU countries are already limiting their energy supply to data centers. Ireland is, there is a full ban on new data centers. In Netherlands, you cannot get energy from the grid. In another, I don't remember where in which country, but there are data centers being built but not connected to the grid because there's just not enough energy in the grid. All that said, this is the average utilization of our data centers. Yeah, just this. Yeah, so 10 to 20%. So average, yes.
So you mentioned the data centers not connected to the grid. Do they do garage sales?
They might soon. So the thing is that if you look in EU, every data center building solar panels and wind energy, and they're talking about nuclear reactors next to the data center, right? Because they're massive, massive, massive energy consumers. Again, 10 to 15, actually 15 to 20% utilization of data centers, right? So this is quite amazing, right? Obviously, none in this room has this problem, right? None of you is utilizing 15% of your data centers, right? Everyone here is at about 80 to 90 recommended utilization. Yeah, but there are other people. So just a bit of reason why it's happening, a bit of historical context is like I started my career in end of 90s. So I missed this craftsmanship era where, you know, everything was done sort of randomly and, you know, like people just built things, yeah? But I came to work in IT when we were full waterfall, right? Everything predictable, everything controlled, nothing moving anywhere, right? The problem was that we couldn't actually change anything because it took, you know how it works, right? And then the Agile basically allowed us to change direction. And although Agile originally came from Toyota Production System, which is actually all about optimization and low cost of production, but it somehow shifted into actually what was needed at that point, which is change of direction. So Agile allowed us a lot of innovation and support explosive growth at the cost of enormous waste. Right now, most of the IT systems are extremely wasteful. Anyone recognizes this problem? Like this? No. I can tell you, like, and I understand this, especially looking at, like, watching the previous talks. It doesn't feel like people in this room aware of this problem, right? But me doing consulting for 10 years, mostly in Europe and US and other places, this is the normal. This is how the world works. So it's not just, again, it's not just a tree hugging exercise. There is massive amount of capacity available for taking.
Looks
Right?
like the Pareto rule.
Yes. So what are the bad ways to actually talk about sustainability? The worst part is greenwashing, which is talking, not doing, right? A lot of companies doing it for decades. This is an example from a big company that not mentioned in the name, but you know. So there are all kind of exercises how you can say that you're doing green things, but actually not do them. In this case, they have, I'm actually talking about later, but there's 3 scopes of carbon emissions. Scope 1, which is what you burn. Scope 2, the electricity you're using. Scope 3 is everything else. So Shell, for example, they only talk about scope 1 and 2, and they are systematically going down in scope 1 and 2. But 95% of their emissions are from scope 3. They actually sell oil and gas, right? I mean, they don't count that. That's not very green. The other way is carbon offsets, which is very easy. You burn carbon, then you buy some offsets, like a forest that many people, you know. You pay anywhere between $1 to $80 per carbon emissions ton, metric ton of carbon emissions. And, you know, you can feel good about it. But it's actually mostly not real. There is very nice show about this. It's 20-something minutes, and it's like, it's amazing show. If you're interested in this, I really recommend you to watch it. It's true.
We don't recommend you watch the Gaza-Israel war episode.
Yeah.
That's not the
So-
episode to watch.
The person detached from the, but this one is actually quite good. Okay, so what is included in IT emissions? It's very important to understand it's not just about electricity, right? It's about scope 1, which is things you burn, like diesel generators. Then you burn diesel, that's scope 1. Scope 2 is electricity, and scope 3 is everything else, which is buildings, roads to the buildings, yeah, the servers themselves. There's embodied carbon that is produced or emitted while producing those servers. There's a lot more than just electricity. So using solar panels is not a full solution. So what it means is that we need to do three things, basically, if you want to optimize to avoid climate change. One is energy efficiency. So use less energy or greener energy. Actually, no. Use less energy here. Use less hardware here, so less servers. It's better to use 1 server than 2. If you have 2 servers, 30% capacity, it's not very smart way to go in any way. And then carbon awareness, meaning you actually need to know what's the carbon mix in the grid, right? So what's the, how green the energy that you're consuming. So there is a Green Software Foundation, which is a foundation similar to CNCF, the Cloud Native Computing Foundation, is the sister foundation, which defines all kind of standards. So they basically created a single number that includes all those things. The energy, the carbon intensity, embodied carbon per unit. So what you really want to get to is, like, you're building, let's say you are at Twitter, right, or X, yeah? And what you really want to know is how much emissions emitted per tweet, right? And eventually you will need to provide this information to your customers in very similar way as, let's say there is nutritional value on food, that you read how much calories and how much different stuff is in the food. The similar is coming to environmental impact. So on each piece of everything, you will have to report what is actually included, how much carbon was emitted. So you need to know these numbers. Not right now, but quite soon. And as every other transformation, it doesn't have to be like all or nothing. So there is quite, no need to go into this, but if you want to know more like what it means to be mature in terms of sustainability in IT, there's just quite a lot of information in Green Software Foundation. Right. So now moving a bit, what can we do? Right. First, the Agile is really a solution for innovation and for speed of change, but it's actually a big problem because it creates a lot of waste, right? And multiple talks today were about that, how to optimize the systems and reduce the waste. And actually, Agile is perfect in the beginning of product lifecycle. When you're starting a new project, you really don't want to go and open tickets to buy a server and then you go through all kind of like things that we did in 90s. Right? What you really want is to go to the cloud, quickly start things and start adding capacity and then do auto scaling and all those nice things. But there was this really good talk about the cost of servers switching from one type of VM to another type of VM. So the one thing that in my experience is happening is not that people are optimizing and always improving, but when they hit a problem with capacity, they add more hardware and they never switch back, right? So because it's cheap and easy. When it's cheap and easy and it's marginal, the cost is marginal, then 5 years later, you wake up and your cost is like 3 million euro on the cloud, then maybe you will invest a bit in optimization. But even then, if your revenue is 100 million, it doesn't really matter. I mean, it's marginal. So that's the reason. So there is overcompensation on, so overinvestment in hardware, over-provisioning of hardware in case to increase the speed of development, the productivity. And it's basically, we need to make sure that we are not over-investing in metrics like DORA metrics, which the majority of them are actually currently Google-driven. DORA metrics are actually measuring the productivity of the development teams, so CI/CD, speed of development, speed of delivery, and things like that. But there are other more lean methodologies, so the methodologies that are more about optimization and continuous improvement rather than speed of delivery. So things like SRE, they have actually skip that. SRE have the 4 golden signals. It's all about resilience, right? Resilience and reliability of the systems. So that is actually quite much closer to optimization than the DORA metrics. Then there's FinOps, which is all about optimization, but FinOps is a bit problematic because people are they don't really care about money, right? There is not much motivation in reducing cost. Maybe for CFO, but not for engineers. And and also, it's very transactional. It's like, oh, it cost me another 3,000 euro. Well, okay, fine. Yeah, I don't mind. Yeah, I have the money. So if it's about carbon emissions, it's a matter of principle, right? It's a matter of saving the planet. The motivation is intrinsic versus transactional, right? And then there is the actual emissions metric, which SCI, it's already ISO standard, so it's hopefully going to be used somewhere, somehow. It's very difficult to calculate at this point, right? But eventually we'll be okay. Yeah, and DORA metrics are for productivity. But what's important is to make sure that the company actually understands in which stage the product is. Each product is in development stage and change stage, then relax the optimization strategies and make sure that we can go faster. But once the product is in production at scale, something like Gmail, it doesn't change every day. It shouldn't change every day. So it should have, and Gmail is very much optimized on large scale. Right? So this kind of products, when they get to scale, it's all about optimization and reducing cost, reducing carbon emissions, and the speed becomes less relevant. Okay, few measurement tools that are actually already available. So the first one is Kepler. This is a very specific tool that it measures energy consumption for everything running inside Kubernetes, right? It doesn't actually give you the carbon emissions, it gives energy consumption, which is one step towards carbon emissions. It can give you carbon emissions, but it's very rough estimation based on, without considering the complexity of calculation. But it gives actual energy consumption in joules, and so that's an important tool. It's almost, I mean, those two tools, this and Scaphander, there's more or less the only two tools available today to actually calculate energy consumption from IT systems in any meaningful, real-time, accurate way. Scaphander is only on physical hardware, so it doesn't work in the cloud, and Kepler is only in Kubernetes, so it doesn't do other things. And we are building this tool, which is already somewhat available, Ether, so which is converted to the actual emissions. It integrates with Kepler, but it also can go directly to the cloud and actually collect the energy. Actually, it collects the actual consumption of resources like CPU, memory, and stuff like that, and then the carbon mix in the grid, and then makes all the calculations to get to these numbers. And this is also open source. So, but go deeper, there is also quite few tools to actually go deeper into actual coding. So basically, line by line, tracing and figuring out how much energy each line of code consumes. I would not recommend to go into that at this point. It's actually not very efficient because majority of the waste is actually on infrastructure level, but those things are available. There are a couple of really good talks by ING Bank and by Firefox that they're actually showing how to do it. It's the same as profiling for resource optimization. So, yeah, good talks, not going into more detail. There's a lot of excitement about this, that programming languages, they have really, really different energy consumption between 1C to 80 on Perl. Yeah, so 80 times more consumption in Perl. Yeah, there's no assembly, yeah. But the Rust is very close to C, right? So anyway, just saying, this always brings a lot of excitement, like, but you always need to consider that the cost of refactoring might be dramatically worse than, like, so don't do that. Don't switch languages. Yeah, so most of the benefits can be done with just simple things, right? Just don't wait. Like, switch off the lights when you're leaving the room. That's like most of the savings. Yeah, and the other thing is, it's actually important to choose greener areas, right? So explicitly comparing Israel to Sweden, right? So there's 23 grams of carbon emissions per kilowatt hour compared to 484 in Israel. This is from yesterday. Yeah, this is very nice product called Electricity Map. You can do all kind of like measurements real time.
This is for the
That's the grid, yes, that's country grid, and you can go deeper on different regions and stuff like that. Oh, you can't do that.
What does Sweden do?
So,
They don't do anything.
and the other thing is, we always need to remember, it's not just about electricity, it's also about actual hardware. So this is embodied carbon, the carbon produced while actually producing the server. This is a typical Dell server, over 7 tons of emissions, and it needs to be amortized over the lifespan of the server, right? And what Amazon actually announced at some point this year, that they extended the lifespan of the servers to 6 years and saved $900 million. Yeah. Which is just, you understand how like reasonable this decision is, right? It's the same server, it works fine. Why wouldn't we use a bit longer? There is another company that they figured out that the worst component in the physical hardware is the RAID controller. In all their servers, it's physical. and it's hardware, and in modern ones, it's software, so they replaced that, and now they can use the servers for 10 years. Right, so at the end, in our experience, about 50% of all the reduction can be done on infrastructure level, just not over provisioning and not, having like wasteful. Like, there's so many stories I can tell, but I have no time. About another 20 to 30% can be reduced on better algorithms, better software, right? So greener software development practices. And there are other things, but they're not that important, right? What it basically means that we can reduce 80 to 90% or 70 to 90% of carbon emissions, which translates into money, yeah, and still get the same value to customers. Right? And the things that we recommend to start with is basically start learning, right, and put metrics in place. There is nothing wrong with putting a bit of metrics in addition to other metrics like cost or performance or speed of delivery. Just put in metrics for carbon emissions and see what happens. Right? And the last thing is back to bananas. So we said somewhere it's easy answer, somewhere in the middle. But actually, bananas are actually quite good. They are not, compared to amount of emissions per calories, amount of calories, they are actually very good as food goes. The worst one is beef and lamb, and then it goes to, mostly it's vegetables. They are much better. And I'll go through a few other things, just a couple interesting ones. Cryptocurrencies is a 0.12% of entire worldwide emissions, right, including everything. It's this stupid cryptocurrency thing, right? It just makes no sense. It's 68 million tons per year for just cryptocurrencies, mostly mining. The other thing is... כן. not 12%, 0.12%. זה לא הרבה?
קריפטוקרנסי, כאילו זה לא כזה רחב, זה לא כזה בשימוש רחב. אם זה יהפוך להיות משהו שבשימוש רחב זה...
There is no actual, you see, the mining is not the point of cryptocurrency, right? I think just mining is like, without considering the impact on the environment, like, why would we do mining? Isn't there a better way to actually produce them? Just saying, right? It's a long conversation that, yeah. Another thing is typical laptop or phone, 85% of the carbon is actual physical device itself. So before you actually buy a phone, already emitted 85% of the emissions. About 2% is electricity it will consume over the lifespan of the device. And about 15% is the services around it, Gmail and all kind of other stuff. So it means that when you buy a physical device, a phone, every 2 years instead of every 3 years, that's a significant impact. When we replace laptops and stuff like that, if we can drag them for longer, as long as they are useful, that's actually a very significant impact. The last thing I will say is that bananas, right? So there is a very interesting metric. If you cycle, yeah, you would assume that cycling is free in terms of carbon emissions because it's human energy. But human energy comes from food, right? So if it's powered by bananas, it's 40 grams per mile. Yeah. If it's powered by airlifted asparagus, it's 4.7 kilograms per mile.
And if it's ship freighted?
Yeah, less. But compared to cheeseburgers, it's 310 compared to 40, right? So 8 times more. Yeah, recommend those books if you like. And the feedback.